Hello, Coach Holmes here, and today we're going to be talking about centroids and orthocenters. Okay, now these are something unique and new, so make sure we actually follow along. First off, what we need to know is we need to know what a median is. A median is a segment from the vertex, which is just any corner of a triangle, to midpoint on an opposite side. So basically, you don't have to draw this, but basically it's the so if I have a vertex right here, it's going to be the opposite side of this, but the midpoint. All right? So it's going to be the midpoint of the opposite side. Now, when we have medians together, when we have medians in all three vertex, we actually create what we call a centroid. It is a point of concurrency when the medians intersect. So that's very important to keep in mind, that centroid is when we have medians. Okay? And we'll discuss more about how to find centroids in a minute, or to use the significance of it. But next, we're going to talk about altitude. Altitude is perpendicular segments from vertex to side. Okay? So basically the altitude is kind of like your height. When you're trying to find the area of a triangle, it's kind of like your height from the top of the triangle down. That's basically what an altitude is. It's basically the height of a triangle, how tall or how long it is from the height perspective. So now orthocenters are concurrent points, or the point of concurrency when altitudes intersect. Okay, so basically the orthocenter is when I have a point of concurrency from altitudes. All right, so basically we have four different triangles. We have four different points of centers from a triangle, one dealing with perpendicular bisector, angle bisector, median, and altitudes. So it is very important to keep in mind which one makes what. But today we're going to be focused on centroids and orthocenters. So remember that the median makes the centroid and the altitude makes the orthocenter. Now there is something unique about centroids as far as what it does. In a centroid theorem, it states that centroid is 2/3 of the distance from the vertex and midpoint. All right, so a centroid is 2/3 of the distance from both the vertex and midpoint. Okay, now a better way to classify this, to me, this would be a better way to classify the distance. To me, this is the better way. AP is equal to 2 times PA. So So this distance right here is double this length. And what I gotta keep in mind is that it's the distance from the vertex to the centroid is twice the distance from P to F. Now some of you may be wondering, well, why are you putting 2 times PF if it's double? Well, I gotta double this length to get to AP. Okay? So this is twice as big, so I gotta make this 2 times bigger. That's basically why. So if I look at this, so right here, here, and here, those are 2 times, those are double this length in blue. Alright? So for example, if I want to solve for each of these, so I want to solve for y first. I know y is 2 times 6. So if I double the 6, I get y equals 12. So now let's look at this, let's solve for x. So I know 15 is equal to 2 times 2x. Because remember, the side in green, it's bigger, at least double. So I gotta double the smaller length to make it equal to each other. So 15 equals 2x, I get 15 equals 4x, divided by 4. And I'm just gonna leave it as a fraction of 15 over 4. I'll just leave it as a fraction. I'm not gonna change it. So that's how we solve for x. Now remember, now for for z, 2z plus 4 equals 2 times 2z. So now all I gotta do is double the 2z, which is 4z. And I just realized I made a mistake, a minor mistake anyways. That's not x, that's z. My mistake, guys. But still, now we gotta solve for z. So subtract 2z from both sides. 2z equals 4. Divide by 2. And I get z equals 2. So that's how we're going to find the variables or the length of those figures, of those sides. Okay? So what we got to remember is that from the vertices, or from the vertex to the centroids, it's double from the centroids to the midpoint. Okay? So the vertices is going to be bigger, midpoint is going to be the smaller length. Okay? Now next, I gotta find the centroids on a graph. So here are my points. So I'm gonna plot these points real quick. So I got 0, 4, 1, 2, 3, 4. Negative 4, 2, 1, 2, 3, 4, 1, 2. And then 7, 1, 1, 2, 3, 4, 5, 6, 7, 1. I'm going to draw my triangle. Now I'm going to change the color real quick so that way I know which one I'm looking for. Oh, I'm sorry. I messed up on the points. Glad I saw that. Because it's supposed to be negative 4 and negative 2. That's my mistake. That looks a lot better. Now, so again, one of the things I gotta do is I gotta find the midpoint for each one. So I gotta find the midpoint for each side. So the first thing I gotta do, I want to find the midpoint between A and B. Let me do it this way. So the midpoint for A and B, my x value for A and B is 0 plus negative 4 over 2. My y values are 4 plus negative 2. Now, 0 minus 4. Now, I know the plus makes it plus and a negative makes it a minus. So 0 minus 4 is negative 4. 4 plus negative 2, that gives me a positive 2. Divide them out. So the midpoint between A and B is negative 2, 1. So that's my median. Now, when we are talking about concurrent, we know that all three are going to intersect to each other. So really, if we really just want to find the point and just be done, we just got to find two lines of intersections and then we're good. But I can do a third one just to be safe, to make sure that really is my point. So if you're just looking for the point, you just need two lines. To be certain, you need three. So looking at it, I want to do, let's do BC. So my x value for B and C is negative 4 plus 7 over 2. And my two y values are negative 2 plus 1 over 2. And I like this one because this one's going to be a fraction. I can already tell. So I know negative 4 plus 7 is 3 over 2. Negative 2 plus 1 is negative 1 over 2. I can't simplify it any further, so I'm going to say 3 over 2, negative 1 over 2. Negative 1 over 2. Well, actually, let me change that. I could turn it into a decimal because a decimal would be a lot easier to put it on a graph. 1.5, negative 0.5. So I know 1 and a half right here. Let me try to, there we go. I want to make sure if I got the right point. So my point of intersection happens to be right here. So the centroid of this is 1, 1. So that's my centroid. So if I actually find the midpoint for the next one, probably be about right here somewhere. But again, all you gotta do to be certain is find the midpoint between A and C. Find the midpoint between those 2 points, and then draw the line, and certainly you should be able to intersect this point right here. But I want to move on because I don't want to wait just because of YouTube restrictions on 15 minutes. Next, I want to draw my triangle. 1, 2, 3, 4, 5, negative 1. 1, 2, 1, 2, 3, 4. 1, 2, 3, 1. So I have my triangle. Let me draw that a little bit better. There we go. So remember, orthocenters are altitudes. So it's basically just perpendicular. So it's basically a perpendicular through a side from the vertex. So basically, since this is horizontal, I'm going to do this one for sure because I know that this is a vertical line is perpendicular. But I want to start from the vertices and be perpendicular. Let me make that blue so that way we know the difference. Just like that. Now I do want to go through just in case it might be outside. Because some triangles, some of the orthocenters could be outside. Next, I want to find the slope between these 2 lines. So level it real quick. X, Y, Z. I want to find the slope between X, Y. So I do have to find slope. I'm going to do it in green real quick. So I go 1, 2, 3, 4, 5. 1, 2, 3. So remember, if the slope is 5 over 3, perpendicular slope requires me to not only to flip the fraction, but make it a negative. So I'm going to go backwards from 1, 2, 3, 1, 2, 3, 4, 5. And just so happens, it happens to be right on that line. So here's my perpendicular line. Let me go ahead and erase this part so that way we can see it. But we already have an intersection. So the intersection of the orthocenter happens to be -2, comma, 1, 2. -2, 2. Now, there's nothing unique about orthocenters as far as the distance and stuff. So the main focus for orthocenters is to be able to find it on a graph. But remember, from centroids, finding it, find the midpoint of the segment, draw the vertices to the midpoint. But to find the distance, remember, it's the vertices to the centroids equals twice the length of the centroid to the midpoint. Thank you, and have a good day.